My name is Nakaungu Teddy, a computer science student, year 3, Macquarie University, and I'm from group 4, that is computer graphics. And I'm going to present on advanced computer graphics education content authoring for Refugee accelerated competence-based curriculum. And I'm going to also talk about some papers that I was able to review. So this work is basically looking at how new AI technology, especially large vision and multimodal models, can help us generate education graphics, animation stories that are tailored to the needs of the refugee learners in Uganda. So, when it comes to the overview, traditionally, computer graphics education content has been created manually using tools like Blender, like Unity. But then we realized that this process is, first of all, very slow. It's technical and it's not at all scalable for large numbers of learners. And then the other thing is that today, besides that, we've seen a shift where we've seen large vision models that can generate 3D scenes, animated characters, and even produce entire visual stories automatically. But then the challenge is that if the generated content is not culturally relevant or aligned to Uganda's context-based curriculum, then the refugee learners are more likely not to benefit fully from it. And that's why I propose retrieved augmented generation to ground AI output into local context curriculum goals and also have a feel of real refugee experiences. So then, on the other side, when reflecting of that shift and then the previous lecture, I realized that the focus is no longer just on designing models manually, but then rather it's about fine-tuning existing models, designing a pipeline, and ensuring culture and educational alignment. So that means that our role is changing from asset creators to pipeline designers. And then we also have to put into consideration the fact that real-world impact also matters, which means that the content we intend to produce must be multilingual, it should be lightweight for the low bandwidth areas, and also culturally adapted for refugee communities. So that takes me to my other slides. These following slides go through the papers that I reviewed. So the first paper I reviewed was about the mini GPT-4. This paper replicates the GPT-4's vision language abilities with a much smaller architecture. The problem it addresses basically is that existing models require massive data sets in most cases. They require large data sets, and then in most times they hallucinate image captions, meaning that they struggle with spatial reasoning. So when we look at its architecture, it's first of all simple, but it is efficient. And it uses a vision transformer to extract image features and then projects them into a language space, and then connects to a virtual large language model. So basically, the mini GPT, for it proves that we can build lightweight systems that still achieve strong performance. And for our case, it is important because refugee learning solutions must run on limited resources. However, its weaknesses like hallucinations and then limited spatial reasoning means that we cannot use it all. It's not perfect for educational use without further fine-tuning. So that's with the mini GPT-4. It requires fine-tuning, in order to align it with educational use. Then I also reviewed another paper, which is the Queen 2.5 VL model. And for this one, first of all, it's from Alibaba. And unlike the mini GPT-4. This one is a very powerful vision language model that can handle not just text and images, but also documents, graphical user interfaces, and even videos. So for it, its key innovations are dynamic resolution processing, temporal grounding for video understanding, and also window attention for efficiency as the model tries to identify the features. So it comes in different sizes, like from the 3 to 72 billion parameters. So it's there are 3 billion. The models are between 3 billion parameters to 72 billion parameter models. So that is how big it can go. So that's its architecture. The diagram simply shows the framework, a demonstration of its framework. And then for the implementation, the model is relevant because it's practical for tasks like document analysis, like optical character recognition, summarizations, and even robotic graphical user interface control. So that means in our case, for the case of education, it means that it can analyze documents, summarize like long videos, which could be very powerful for creating and delivering like educational materials like we intend. So, so that's the second paper. Then I also reviewed another paper, which is the PHI 3.5 vision model. So this one, for it, it's from Microsoft, first of all. Then, and in this case, this one is smaller. It's a smaller, efficient model with just 4.2 billion parameters, but still, it competes strongly with much larger models. So for it, it focuses on three main areas. One is single image tasks, for example, like visual question answering. And then the other area it focuses on is multi-image reasoning, like for example, artwork, or even forensic analysis. So the third thing it looks at is video tasks like temporal reasoning across frames of the video. So its architecture is trained with supervised fine-tuning and direct performance optimization for safety. And that is very important because we need models that won't generate harmful or inappropriate content for the children. So and then for the case of refugee education, this vision model is very useful because it balances the efficiency with performance, making it more deployable in real-world environments with low resources. So that's with the PHI 3.5 vision model paper that I reviewed. Then I also reviewed a fourth paper. For it, it's about the M-plug-all model. And for this fourth paper, for it, it introduces the M-plug-all, which takes another like modular approach to multimodal AI. So the problem it solves, sorry about that. The problem it solves basically is that most large language models are strong in text, but then weak in processing visuals, and its architecture adds a visual knowledge. Its architecture adds a visual knowledge model and a vision abstractor, then aligns them with a language model in 2 stages, like it appears in the architecture. So still about this M-plug, what's powerful about this model is that it can generate multimodal content without compromising the strength of the text. Like it can do different model contents without compromising the text generation. And then for our case, this model design is promising because it can be scaled or adapted depending on the tasks. For example, if we are to generate educational stories that combine images and text like seamlessly, then this model would be a great option. Then I also looked at a fifth paper, which is about video LLAMF. And for this final paper, like unlike the others, this one specifically focuses on video understanding and also combining both visuals and audio inputs. So the challenge it tackles is that most models either look at static images or only at audio, like it's static images or audio, but they cannot capture temporal dynamics, like the things, the way things change across time, like when a video is playing, like some models cannot capture those dynamics. So this video LLAMA uses two branches. It uses a vision language. It uses a vision branch that is for video frames, and then it also uses an audio branch that is for speech, all sounds. And then, so both of these two branches align together. They align together with a language model to allow audio-visual reasoning in between. So that's the architecture. It's architecture diagram. It shows the flow. And then this, with relevancy, this model specifically is especially relevant for us because our goal is to create educational videos. So by combining the audio and then the visuals, this model directly connects to our use case of generating interactive lessons and storytelling for learners. Then, if I'm to continue with the proposed architecture, after building on those insights, this is the proposed architecture for the refugee education content authoring. This is how it flows. This is how the architecture flows. So first of all, the inputs include three things. It includes video frames, that is through a vision encoder, like the BLIP2 model. And then it also includes an audio track through an audio encoder like Image Blind, like you can see in the architecture. And it also takes in text prompts or queries from the user, what the user can input as text. So in processing, we use a video and audio cue formers to align temporal and multimodal features. And then the projection layer, which is this, the projection layer, for it unifies everything into a single embedding space, like you can see in the diagram. So the reasoning step is powered by a large language model. Like that is if we're to look at options like the previously discussed, the LLAMF, the 2.3 VL, and the rest. So to ensure that the output is culturally and curriculum relevant, then we integrate the retrieval augmented generation with local context-based curriculum materials and refugee context, basically. So we need to be specific with that in order to bring out the alignment with the curriculum and then the culture. And finally, the outputs can be text. They can be text scripts. They can be question and answer pairs. Like you ask the model, then you ask something, then you get a response, and it can also be storyboards, like a full story being told, then which are then sent to the text to animation module. Like in this case, we may say that Unity and Blender can then render the final 3D animation videos for the learners to watch. So basically, that's all with the architecture. So this pipeline is designed to be automated. First of all, it is designed to be automated, like automatically generate, and then it is designed to be scalable. It is also designed to be sensitive to culture and educational needs. And in that, we want to ensure that refugee learners not only get content, but content that is meaningful and very accessible to them. So we have seen how advanced vision and multimodal models, like from the mini GPT-4 to the LLMA, are changing the way we generate and deliver educational graphics. So I think instead of spending weeks modeling in Blender, we can now fine-tune models and automatically generate interactive localized stories that align with Uganda's curriculum and the needs of the refugee learners. That means we are putting everything into consideration. Therefore, this work, I think it's more about technology. It's about making education scalable, multilingual, and culture relevant in places where it is needed most, and that is in the refugee communities. That is all I had. Thank you.